Students, these examples are important for examination point of view. I will send you the PDF form of all pages. Please do these examples carefully. Now the next topic is accuracy and precision. Accuracy means closeness of the measurement to the true value of the physical quantity. Means if we reduce the error, the measurement becomes more accurate. Precision refers to the resolution or the limit to which the quantity is measured. It is determined by the least count of the measuring instrument. The smaller the least count, greater is the precision. Let us take an example. You know that the true value of acceleration due to gravity is 9.8 meter per second square. Two students perform the experiment to find the value of g. One student measures the value as 9.7. Another student measures the value as 9.62. It is clear that the difference between true value 9.8 minus 9.7 is 0.1 and another value it is 0.18. Difference is less in this quantity. So 9.7 is more accurate, but 9.62 is more precise because it has smaller least count. It measures up to 2 decimal places. Or you can say that more is the significant figures, more is the precision. Is it clear? Next topic is errors in a measurement. Error means difference between true value and measured value. Like in our example, true value is 9.8, measured value is 9.7. So error is 9.8 minus 9.7, that is 0.1 meter per second square. Learn formula for error. Error is equal to true value minus measured value. Now next is the different types of error. Number 1, constant error. Constant error means error which affect each observation by the same amount. Like you do the experiment 3-4 times. In each and every experiment you get the value 9.7. Means the error is by the same amount. This error is due to the faulty scale or faulty instrument. Next error is systematic error. The error which tend to occur in one direction, either positive or negative. Means you get the measured value like every time by less by 0.1. Means your error is 0.1 positive. If you get the value of g 9.9, means you get the error 0.1 negative. There are of following types. Number 1, instrumental error. These systematic error occur due to the defect of the measuring instrument. Means the instrument is defective. Number 2, technique. There is some error in the experimental technique due to some limitations to perform the experiment. Number 3, personal errors. Personal errors varies from individual to individual. It is due to the individual carelessness in taking the observations or the lack of proper setting of apparatus. Number 4, error due to external causes. External causes means change in temperature, pressure and wind. For example, the reading of the apparatus is different in summers and in winters. These errors are due to the external causes. Next type of error is random error. Random error occurs irregular, randomly. These errors occur by chance. We don't know the cause. In one time you get the value of g as 9.7. In another experiment you get the value of g as 9.9 or 9.89. Means you don't know the reason why this error occur. Next error is least count error. This is due to the limitation imposed by the least count. Students, the least count is smallest division on the scale of the measuring instrument. Like the normal scale you used, its least count is 1 mm. Next is the gross error. Gross error is due to the carelessness of the person or due to the improper adjustment of the apparatus. Please learn these errors properly. They will come in the form of MCQ form or true false or in the form of fill-ups. Next, another categorization is absolute error, relative error, percentage error. Absolute error means difference between true value and the individual measured value. True value can be measured by the arithmetic mean of all the measurements. Learn these definitions carefully and do numericals on these types of errors. Number 1, absolute error. Next is the mean absolute errors. Suppose we have 6 quantities. We will find out the absolute error for each and every quantity. Then we will take the mean. That is the final absolute error. Next is relative error. Relative error is the ratio of mean absolute error to the true value. If you find out the percentage, then multiply relative error by 100. These numericals are very important for the examination point of view. Do these numericals carefully. I will send you the PDF form. Next topic is combination of errors. Combination of error means when you have two different quantities, you are going to add it, subtract it, product or divide or par. These derivations are in syllabus, but these derivations will not come in my exams because my exams are purely objective. You learn only the end result, like in the sum of two quantities. Suppose we have two quantities A and B. Delta A is the error in A. Delta B is the absolute error in B. Z is the answer. Z is equal to A plus B. Then the total error in Z is delta Z is equal to delta A plus delta B. If you add two quantities, then the error is sum of absolute errors in the individual quantities. Similarly, if you subtract two quantities, Z is equal to A minus B, then the error in Z is equal to delta A plus delta B. Means error is equal to sum of absolute errors in the individual quantities. Students, remember one point, errors always added up. Either you add two quantities or subtract two quantities. Next is the error in the product of two quantities. A and B are two quantities. Z is equal to A into B. Please learn only these end results. Delta Z upon Z means relative error in Z is equal to delta A upon A is relative error in A plus delta B upon B is relative error in B. Means the relative error can be written as fractional error. The maximum fractional error or relative error in the product of two quantities is sum of the relative error in the individual quantities. Similarly, if you divide two quantities, Z is equal to A plus B, again the end result is same. Fractional error or relative error in Z is equal to fractional error or relative error in A plus fractional error or relative error in B. Please learn these end results properly and do the numericals. Next is error in the power of a quantity. If you have z is equal to a raised to the power n can be any number, then the fractional error in z is equal to n times the error in a. Generally, if you have a quantity z is equal to a raised to the power p, b raised to the power q upon c raised to the power r, then fractional error in z is equal to a raised to the power p, means fractional error in a is multiplied by p, plus q into fractional error in b, plus r into fractional error in c. If you want to find out the percentage error, then multiply the whole equation by 100. Thank you.